Alright guys, we're on section 12.1, talking about angles of triangles. How are the angle measures of a triangle related? Let's go do some vocab. Actually, okay. Yeah, I guess we'll do this first. So yeah, this is a pretty large amount of vocab, and even though it's not right here, you should still write them down. So a scalene is when the triangle has three different sides. So it's like a pretty generic triangle. One that you would randomly draw without a ruler is probably going to be a scalene because you don't have the tools to like make it the same anywhere. An isosceles triangle has at least two congruent sides, so it has these marks right here. So since they have the same number of hash marks, like one here and one here, that means they're the same. And also, it's not in the picture, but I'm like telling you that when sides of a triangle are congruent, the opposite angles are also congruent. So this side is pointing to this angle, and then this side is pointing to this angle because they're like across from each other. And so if these sides are congruent, which they are in this picture, then these angles, these two right here, are also congruent. So one right there, the other one right there. An equilateral triangle, so equi means equal, and then lateral means side. So three congruent sides, three equal sides. So an equilateral triangle is always equiangular. If all the three sides are congruent, then that means, so for instance, this side is pointing to that angle, this side is pointing to that angle, and this side is pointing to that angle, then if all the sides are congruent, then all the angles are also congruent, which is equiangular. An acute triangle is when all three angles are acute, and so don't forget that when you're measuring an angle, this is like the flat side, and so what does this do? So for instance, if I had an angle like from here to there, that this angle right here would be 10 degrees. So if you're using a protractor and you flip it around, an acute means less than 90. So yeah, like if I was looking at this angle, if it was 90 degrees, if it was a right angle, then it would be like boom, then boom, straight down, right? But it's not going straight down. It's like finishing before that, and so this has to be less than 90. If this angle right here was 90 degrees, it would be here, then here, but it's not. And then lastly, if this were a 90-degree angle, it would probably look something like this, here to there. But again, the angle, it's an acute angle, so it's less than 90. If we have one right angle right here, exactly one, then it's a right triangle because it's a right angle, right triangle. So three angles, triangle, three angles, one of them is right, one of them is 90, so there. An obtuse angle, so again, obtuse means greater than 90, but less than 180, and so an obtuse angle, if it was 90 degrees, then it would be like this, straight down. But since this opens up past the 90-degree mark, then it's obtuse. So yeah, we have the triangle sum theorem, which is that the sum of the measures of the interior angles of a triangle is 180. So that means interior means inside. So inside, 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 and these three would add up to 180. And so if they all add up to 180, don't forget that if any one of these angles gets bigger, then that means one or the other two have to get smaller, right? So if we started off, let's say if this was like 170, if angle A was 170, then this would be could be like 5 and 5. But if this is 178, then this could only be 1 and 1, or 178, 1/2, and then 1.5, or something like that. But it has to add up to 180. So, yeah, should I do a sample problem? Sure. I talked. It's just going to be exactly what I said, but maybe some of you need to see like me doing calculations for it to make sense. So that's what I will do. So if I knew that angle A was like, let's say 18 degrees, and I can't do the degree symbol on my keyboard, but pretend it has a little circle right there for degrees. This is 18, and this is like 52. Again, I am not even measuring it, I'm just making stuff up. So you'd say 18 plus, angle B, and again that's kind of crappy because I don't know how to type angles on the keyboard. Plus 52 equals 180. Then you could put them together. 18 plus 52 is 70. 70 plus angle B, measure of angle B, is equal to 180. We get B by itself. So measure of angle B is equal to 110. So I just made this problem up, but if you know any two angles, you find the third one. You can find the third one by knowing that they all have to add up to 180. The exterior angle. So exterior means outside. So this right here, so this angle is inside, this angle is inside, this angle is inside, this angle is outside the triangle. Is equal to the sum of, sum means, what are we going to do? We're going to add. So the measure of an exterior angle, one is exterior, is equal to the sum of, things are going to be added, the two non-adjacent interior angles. Okay, 2 means we're going to look at two angles. Non-adjacent, we will touch on that in a second. Interior means inside. So let's look at this picture. It's saying 1, the measure of angle 1 is equal to measure of angle A plus measure of angle B. So in this context, if it says non-adjacent, like what do you think that means? Right? So where are A and B compared to 1? And so I'm hoping that you notice that it's the two angles that one is not touching or next to, which is what non-adjacent means. Non-adjacent means like not next to. So angle C is adjacent to angle 1, so it's nowhere in this problem. And it says, okay, if we have an exterior angle, you have to add up the two opposite interior angles. So if I had a drawing right here, can I make a line? Make an arrow, I guess? No, I don't want to do that. So if I had an angle right here, this angle, we could call it angle 2, would be equal to, measure of angle 2 equals to measure of angle B plus measure of angle C. And if I had one here, like that, what I'm doing is I'm just extending this line, see? And so, and even though that came out ugly, hopefully you get what I'm talking about. Well, let's delete it real quick. So this angle right out here, angle 3, would be equal to angle A plus angle C. To do that with numbers, if this was, I don't know, 50 degrees and this was 40 degrees. So if measure of angle A is 50 degrees and measure of angle C is 40 degrees, then this angle right out here, pretend that's a straight line, that angle right out there is 50 plus 40. So this angle would be 90 degrees. Or it could be like, just whatever these two added up is equal to that. Corollary to the triangle sum theory, the acute angles, acute means less than 90, so or smaller than 90. So the acute angles, the smaller angles of a right triangle are complementary. So complementary means add up to 90. And so if we already know this adds up to 90, or sorry, not adds up, this just is 90. And I know that they always have to add up to 180. So I'll say, just to make it fast, A plus B plus C equals 180. If any of them ever is a right angle, so in this case 90, then that means the other two have to be complementary. Like, that's just literally how that works. A could be like 30, B could be 60, A could be 50, B could be 40. Well, we don't know the particulars, but we do know no matter what, if one of them, if I have a right triangle, then the other two angles are going to add up to 90. Okay, so that's all. As you go through this, I would definitely, you don't have a protractor at home, so I would go home and use I would literally just, I can link this to you as well. Like, this is to help you visualize, oh, how big are like small angles and big angles. So don't forget, like, as you visualize these, you kind of want to be thinking about it in like lines. So let's see here. So you would think about this extended. So this would make 180, and then something like this, not exactly, but this would be 90. So if we can look at angle R and be like, okay, well, does it even reach the 90 mark? Oh no, like it doesn't, right? And if I was looking at Q, I'd be like, okay, well, this is going to be the 180 mark. And then to split it up in half, this would be the 90, about 90 degrees. So is angle Q greater than that? Which it is. And then lastly, for P, if it was, this is a little bit tougher to visualize, but a 90-degree angle might look something like that. So it's on you to be like, okay, well, does that reach up to 90 or not? And so on and so forth as you're just looking at this and considering whether it's an acute, an obtuse, so on and so forth. Acute, sorry, hang on, let me just delete these. Yeah, all right, well, we're just going to pass on this so I can go to the rest of the lecture. But your definitions are right here. Make sure you look at them very carefully before you decide on any of your answers. It could be like a scalene acute, could be a scalene right, etc., etc. Could be an isosceles right, who knows. Find the measure of the exterior angle, so don't forget that the outside one is equal to the opposite interior angles added together. So you would say angle 1 equals 53 plus 53. Or this angle equals these two added together. So here's what that would look like. Angle 1 equals 53 degrees plus 53 degrees. And then 8x minus 5. This is the outside one equals the other two, the opposite two, the ones that it's not touching. So it's not touching these two angles. Add them up. Which is, it's 40 plus 5x plus 15. And then find the measure of the exterior angle. How would you do that? Well, you solve for x, subtract 5x, add those two together, add 5, divide by whatever you get. And then once you've solved for x, then you could substitute it in to the exterior angle to find it. But that's it. So in a nutshell, triangles add up to 180. The interior angles, sorry, I shouldn't say that. The interior angles of a triangle add up to 180. And then you have all these vocab for different types depending on the side lengths and the angle measures. And then to be careful, if you have no clue how to like visualize it, use You can use an online protractor to be like, okay, well, yeah, 0 up to 90. Okay, smaller than that is, oh, like 10. So this angle right here, it would look like this for it to be 10 degrees. There's like an imaginary, just imagine this line connecting this and forming an angle right here. So let me know if you have any questions. But that's it for section 1, triangles. You're going to need to know that a lot of triangle stuff in math too.